In got it number 4, it says you can also zoom out, which we just talked about. The function f of x equals 100 being 100% of the original times 4, meaning it's getting 4 times as far away. Models the percent of the original area of the map after zooming out x times. Graph the function. What is the percent change in the area each time? And that will be a good question for us to answer. It's very good for you to know if something's moving out 4 times, what percent change that is. Let's make our XY chart. Now remember, this time X stands for how many times you zoom out. Up at the problem above, X stood for how many times you zoom in. Alright? So let's just start at the original. Let's start at 0. Since we kind of know 0 means you haven't clicked any buttons, we're going to do 4 to the 0 power, and we're going to get 100 because essentially it's 100 times 1. Now let's say that you zoom out 1 time. Remember, this time X stands for zooming out. So 1 stands for 1 zoom out. That's going to be your original 100 times 4 to the first. So whoa, look at that, guys. It's going up to 400% this time, which is like 4 times as much, right? You're seeing 4 times as much land every time you zoom out. Let's plug in a 2. 4 to the second power. So 100 times essentially 16. Whoa, 1600. It's kind of crazy, right? Look at these. And if you notice, these are the numbers we got. Remember how we did the negatives as zooming out? We're getting those numbers this time because they're making it work, because X here stands for zooming out. Wow, these are going to be really hard to graph, but we can do that. Are you ready? Let's skip by 200s. Yeah, that's actually how much we have to skip by, because look how big these numbers are. So we'll do y-axis by 200. That's crazy. All right? So this will be 200 right here. Then 400 right above it, and so on and so forth. So we're going to go over 0, up 100. Look at that. That's only actually up in between the arc. That's halfway between 0 and 200. Then over 1, up 400. Then over 2, up 1600. So let's see. 2, 4, 6, 8, 10, 12, 14, 1600 right there. Remember, we are skipping by 200s. Look how this graph is climbing up so fast. Now it's going to approach this x-axis over here. What do you think the negatives stand for this time? This time the negatives stand for zooming in. That's why if you look at the two graphs, one compared to the other, since on this problem the negative stands for zooming in, and on that problem the positive stand for zooming in, that is why our graphs are exactly opposite mirror images one of another. So we did part A, we did the graph, but now part B. Part B asks, what is the percent of change? Well, Mr. Lank has taught you how to do percent of change, but I'm going to kind of just help you out. I hope you notice it's going in 4 times each time, right? Each time you zoom in, your land is getting 4 times as big. Excuse me, every time you zoom out, your land is getting 4 times as big. So if it used to look like this, now it's going to zoom out even more, you're going to see even more of it, okay? Now, anytime something zooms out 4 times, or what you're going to, that is a change of 400%. I would ask you this, if 4 is a number, how could you make it into a percent? You would just multiply by 100. Kind of like 1 is 100%, 2 is 200%, 3 is 300%. Okay, that's actually how that works. Oh, this is fun. Problem 5, how to solve these things. Alright, how to solve them kind of when they don't make sense. Like, how do you guys know in this equation, if you have 2 to the x, how do you know what x should be over here so that whatever x is over here, they equal each other on the sides? Well, you're going to use your calculators, okay? I will teach you. Do they have 2 different ways? A lot of times they do these 2 different ways. Doesn't look like they do in this problem, so I'm just going to teach you the way that they do, okay? These calculators are absolutely outstanding and very helpful. You guys should really learn how to take Take some notes on how to use these things. All right. We have no idea how to solve this. You've never learned this. It's not like substitution or linear combination or any of that stuff because it's all kinds of crazy. Here, x is an exponent. Here, x is like a constant type of thing, okay? So what we're going to do is we're going to hit this button, y equals, and you might want to take some notes. I think the notes are under there, but you might want to take your own notes. So y equals. Now, do you see how you have all this empty space here? You're going to clear everything out, and you're going to type the two different equations. So 2 to the x in the first one, and then this side over here, 0.5x, not to the x, just 0.5x plus 2. And you now have two equations. You will typically hit zoom 6, and that's going to give you this picture. There's your exponential function, and there is your straight line. Now, wherever these two cross or intersect is your solution. You guys remember when we did that before with like two straight lines, and wherever the straight lines met was your answer? Same thing here, except this time, look, they cross twice. Here with my left hand and here with my right hand. You're going to follow these directions they have in step 3, but just watch. You hit second. See if I can clear that up. That looks a little better. You hit second, trace, and above the word trace is the word calc. You want to go down to number 5. You want to see where they intersect. Do you see how it says first curve? That just wants to make sure it's blinking on the exponential graph. So I hit enter. And I'm going to try to zoom out so you can see the whole calculator as I do this. Okay. Oh, but then you can't see the screen. Okay, I'm zooming in. I'll just say it out loud. So as long as it's blinking on the exponential function, I'm going to hit enter. And now it says second curve. We'll see us on the straight line this time. Hit enter. And now I want us to take a guess. So you see how I'm using the left and right buttons? I want to take this and I want to move it over. Now look where I put it, right? I put it where they meet. Hit enter again. That is actually your first answer. Your first answer is when x is about 1.4 and when y is approximately 2.7. So if you look at their answers here, they've got 1.45, okay? Which they really probably shouldn't have. They should have put 1.4 if they knew how to round at all. Apparently they don't know how to round. That would be 1.44 even, okay? I'm going to blame the book because that really wasn't me. 1.44, there it is. That's this one. That's the one I just did. Let me show you how to get this negative 3.86. Ready? We do the same buttons. Second, this calc above the trace. Number 5. If you want to scroll down, see how it's blinking on the curve, you hit enter. See how it's blinking on the straight line, you hit enter. But this time we need to move over here to take our guess. So I'm moving to the left one. I already did this one, now I need to do this one. And that is how you get this answer of negative 3.86. And you can see it right there, negative 3.86. So let's try this on your calculator. This might be something good for you to practice when you come to school tomorrow. Okay, just take a look, watch my, if you don't want to watch a video, you want to wait till you can watch it tomorrow in class, that's fine, but if you want to take some notes, just here we go. You hit y equals, you clear anything out that you can, you hit the clear button. You type in your first equation, 0.3 to the x power. You type your second equation, 5, and you hit graph. There's my curve, there's my straight line. How many times is this one hit? Just once, huh? So we hit second, calc. We go and select number 5. Is it on the curve? Yes. Is it on the straight line? Yes. Take a guess. Enter. My answer is, after I throw my pencil around, x, hold on, I need some extra lead here. X equals negative 1.34. Kind of cool, right? That you can get an x value that easy from your calculator. Now what the heck does that mean? Watch, here's what that means. If you take 0.3 to the, my answer, so to the negative 1.34, look how close you get to getting a 5. Now why didn't I get exactly 5? Because I had to round. Alright, watch part B. Again, you can watch this part in class if you want to. You go to y equals, clear your old ones out. You type your first equation in. You go down, you type your second equation in. You hit graph. There's your exponent graph, very slow. And there's your straight line. Watch this, you ready? I'm going to hit second calc. Number 5. Is it on the exponential graph? Enter. On the straight graph? Enter. Take a guess. Enter. Negative 0.45 is my x value. Now remember, that's rounded. So what does that mean? That means if you plugged in negative 0.45 to both of these, you get the same thing. Watch. 1.25 to the negative 0.45. That's the number I get, so about 0.9. And negative 2 times, okay, I'm putting it in for x, negative 0.445. Look at that. I get about 0.9 both times. Why didn't it work out perfect? Because I had to round. Last one, watch one more time, guys. Are you ready? I know this is hard without these things at home, but again, if you want to try it again at school, it might be good. Clear these out. Hit just like you see it. So it was negative parenthesis 2 to the x, then another parenthesis, and then 3/4 x minus 4. So I have my exponential graph, I have my linear graph. Hit graph there. Let's see, there's my exponent. That one goes down. There's my straight line. I'm going to do second calc. Select number 5. Is it blinking on the curve? Yes. Is it blinking on the straight line? Yes. Take a guess. Enter. X is 1.52 when you round. So what does that mean? That means if you plugged that value in for x in both the equations, oopsie, apparently I can't do it properly. Oh, that's 1 point. You're going to get around the same answer. So watch this. 3/4 times 1.52 minus 4. See how you get right around the same value? Again, why aren't they exactly the same? Because I had to round. Now that's it. I do want you to write down this little concept though, okay? There are 4 types of exponential graphs you might see. You might see an exponential graph that does this. Okay? You might also see an exponential graph that does this. Alright? It's the mirror image of the one above it. You might also see an exponential graph that does this. Okay? Or you might see an exponential graph that does this. So you see that one up there? Okay, see, I gotta make it reflect. Okay? I want to teach you the difference. I want to give you a quick example of each one. I know these notes are long, but this is going to be important for our next couple of sections. Okay, you ready? This top graph here would be if you had something like y equals a positive number. Doesn't even matter what number it is, as long as it's positive and it's a number bigger than 1, so like 2 to the x. That's what it's going to look like. Next, this one would be like if you have y equals any negative number, not in parentheses.